Fala, galera, boa noite. Cara, demorou, mas chegou. Com 5 minutos de atraso, tivemos um problema técnico. Eu vou convidar aqui meu amigo Bruno, meu parceiro aí das lives. E aí, Bruno, boa noite, galera. Good night,
Boa
everybody.
Noite.
And we have today a good talk about Reactive Spring with our star, Josh Long, that had a pleasure to meet the first time in the last KickCon in Brazil, in São Paulo, 2019. Unfortunately, this year we didn't have the pandemic. But come on, Josh, come here. And this is Josh, and the stage is all yours.
Thank you so much. I appreciate it. Okay, so hello, everybody. Thank you very much for your time. I know that there are a lot of places you could be right now, and you chose to hang out with me. I appreciate that very much. I see the schedule. We have about 90 minutes. That's not very long, so we're going to go pretty quick because there's a lot of stuff I want to show you. But I wanted to first just thank you for coming. I really appreciate it. I know it's been a weird year. I wish we could have met each other in person this year like we have in previous years. It's been, it's not good. And in Brazil, of course, the situation is pretty bad. Here in America, it's, terrible, So obviously, I'm just happy that we can connect online. At least we still have software and we can have our community, and I appreciate that. I'm on the internet. I'm on Twitter. If you have questions, comments, feedback, whatever, send me a tweet, send me a message on email. I'm happy to answer questions whenever I can and on whatever topic, so long as I can help. Thank you for that. I work on the Spring team. I have for more than 10 years. I have done some training videos. I wrote a book called Cloud Native Java. Unfortunately, I don't think it's available in Portuguese, but hey, maybe. And I have a podcast every Friday. A new episode comes out. It's called a Bootiful Podcast, and it's just me talking to people that are smarter than I am. There's a blog I do every Tuesday called This Week in Spring, and there is a screencast series called Spring Tips that I do every Wednesday, where I look at different episodes and different topics in the Spring ecosystem. And of course, I have my brand new book. It's no longer early access. Right, you can just go buy it now. Right, it's done. It's printed. It's out there. You can buy it. And this book is all about how to build applications that take advantage of reactive programming. And I love reactive programming. Reactive programming is what we're going to talk about today. Now, in order to really appreciate reactive programming, we need to consider why people do reactive programming. What are they trying to get when they use reactive programming? Because remember, reactive programming is not a very new idea. It's been around for a long time, but it solves a problem that I think a lot of us are going to encounter today or these days, right? The first problem is now that a lot of us are moving to service-based architectures where we have microservices, now that we have different services in the system working together, they're collaborating, etc., we have a problem, right? We have now the risk of something failing, of a service going down, of something like this causing an issue. And we need some way to write software that is more resilient, more robust when failure happens. That's the first thing. The second thing that we want is to make better use of the precious few resources that we have in our system. I want to have more resilience. I want to have more resource efficiency. I want to be able to handle more requests with the same code. And so reactive APIs give us a way to do both of those things. It's not a new idea, though. Like I said, it's taken a long time for the need to exist and for the solutions to exist. And so we're finally here. We're finally at a place where these things are here. For the Spring team, the big first step came in 2017, 3 years ago, almost 4. We're going to be closer to 4 than 3 pretty soon, right? Where we introduced Spring Framework 5.0. Actually, it's probably just 3 years because it was September of 2017. So 3 years we've had this, and this release was the first version to integrate reactive end-to-end support, right? I could build reactive web apps. I could do data access. I could use Spring Data. And then eventually we have Spring Data, Spring Security, Spring Boot, Spring Cloud, etc. These make it so that we can build more efficient services. And over time, in the last 3 years, the richness of the ecosystem has become bigger and bigger and bigger. All of it builds on Spring Framework 5. And Spring Framework 5 builds on a project called Reactor. Now, Reactor is a library that we built to support reactive data flow, right? Just basic reactive composition. This library depends on something called the Reactive Streams specification. The Reactive Streams specification is a joint effort. It's a group effort between the Spring team, between Netflix, between the Eclipse Foundation, between Lightbend, at the time they were called TypeSafe. So all of these different organizations got together and we built 4 very simple types, 4 very simple interfaces. And these are part of the Reactive Streams specification. They're so useful. They're so useful that they have been added to the JDK. They're also now part of Java 9 or later. So what we're going to do, my friends, is we're going to walk this journey together today. We're going to look at how all these things come together. We're going to write some software using Spring Boot and using the reactive APIs and using Project Reactor. And we're also going to see that Spring is giving you the toolkit not just to easily build services and software today, but to build the most resource efficient services and software today. So let's go ahead and begin our journey, as always, by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. And here, we already have some interesting choices. For most of our time today, we're going to use the GA version of Spring Boot 2.3.4. But there's some very exciting stuff happening in the milestone versions. And I don't want to spend too long on this, so I'll just show you something that's already there. And you can check it out for yourself, right? This is a project that I am going to be using with my friend Andy Clement. He wrote 99.9% of this code. Andy Clement is working on the native GraalVM support for Spring Boot applications. And so he put together a little sample application. And I just thought this would be very interesting. So I wanted to show it to you. It's a very, very interesting application. Okay, so web, there we go. Okay, and it's just a regular Spring Boot application. That one. I don't know which one is which. There we go. It's just a regular Spring Boot application that uses reactive Spring data, and we're going to cover that in a bit. And it uses a reactive HTTP endpoint, and we will cover this as well. And the only thing that has changed in the code is this: proxy bean methods equals false. So it's a reactive application. You can see we're reading data from the database. You can see we have data being written to a SQL database, Postgres in this case, using reactive APIs. We have a reactive HTTP endpoint, and we have another HTTP endpoint as well. And we are connecting to just a regular SQL database here, R2DBC, Postgres, and so on. The other thing that's interesting is that this application has been built for the cloud, right? So it's got a few features that will help you if you're deploying this, for example, to Kubernetes. First thing that we have is that there's a Graceful Shutdown endpoint. So you can call the shutdown feature. You can invoke the shutdown feature. And if this plugin is enabled, I don't have the Graceful Shutdown here. If you have Graceful Shutdown, let's see here, idea.
Josh, could you zoom a little bit more?
Thank you. Sorry about that.
Okay.
Sorry about that. Okay, so let's open this up, and I'll make one quick change. It's indexing. Font. Is that okay? What about 30? Okay. Is that big enough or too small or too large?
The right just small. The another one they are asking to grow a little bit more in the
Okay.
left, but the in the right is too small.
Okay. So how about that? Or how about 48? Is that okay?
Let me see. No, 48 is no, is small. Yeah,
Too
I'm
small.
seeing too small. I'm seeing in time in the streaming. I think probably try 50 something
It,
or 60.
it's showing me it won't let me apply. See?
Yeah.
Why is that? Okay. Fear of code. I don't understand why. I cannot make it any bigger. Why is that?
Let's see.
Presenter.
I put in my full screen monitor.
Into presentation mode. View. Oh, I'm upgraded to the new version of IntelliJ, and there's just all these new bugs.
In the
All
left
on my
is good. In the left, I'm seeing very well.
right, but most of the day we'll spend in here, so I need to figure this out quickly.
Okay.
Why is it so small? I wonder. Hold on, let's see if I do something else. What if I go displays? Can you still see me?
Yeah. Yeah. It's good.
Is it much better?
Let me see. Yeah, much better.
Is this still okay right here?
Yeah. Yeah, it's better. Much better.
It's okay at 30 right now. It's smaller.
What is it? No, there's some distortion right now.
Okay, so what about 35?
Let me see. I have to. There's a hold on. There's a delay.
Right?
Yeah. Yeah, it's good. It's good now.
Okay. Good. Okay. Okay, so basically this is an application that very, very basic. Well, that's very large, isn't it? Thanks. This is a reactive application, nothing too special. What we need to understand is that I've configured several things in the property file to make it more natural, to make it a better citizen when it runs in the cloud. And so the first thing I've done is I've made it so that the server shutdown is set to Graceful. And I've also made the platform a Kubernetes application. I said that I want to run as though it's on Kubernetes. And so Graceful Shutdown is a feature that's very useful in a cloud environment. You can use Graceful Shutdown to tell the application to slowly it stops taking any new requests, and it slowly shuts down after the existing requests have completed, right? So this is very useful. There's another feature that's very interesting is the health endpoint. The health endpoint now has Kubernetes liveness and readiness probe information. So you can feed that to your Kubernetes configuration, and it'll be able to figure out whether the service is healthy or not in the standard way. So a lot of nice features there, but what I really love is the build file. In the build file, we have done some things that make this a very interesting project indeed. It's using the new Spring Graalvm native project. This is not a GA, it's not general release yet. It's still early, but it works, right? You can see it does a lot of stuff. So you add this to the class path, and then you can configure optionally, you don't have to do this. You can also configure the Spring Boot plugin to do a build pack for you, right? And so the build pack will actually create a Docker image. So you can either create a native image, or you can create a Docker image, or you can create a Docker image with a native image inside of it. And that's what this will do. So I've already got the native image here. I can go here to target, and there's my native image, right? If I run this application, there's the code, right? It starts up in 1/10 of a second, right? 1/10 of a second to get the actuator, to get the HTTP endpoints and the data access logic talking to my Postgres database, all there. So this is a very lightweight application. You can put that in a container. It starts up like that, no problem. You can do you can build the Docker images as well. So you go back here, Maven Spring-boot build-image, and this will build a native image for you inside of a Docker container. And then you can run that Docker container, right? So lots of interesting things that you can do in the new versions of Spring Boot. And you can see here it's building the Docker image by pulling in the build pack and doing all that, right? Very, very convenient. I don't want to wait for all of this to finish. It'll take forever, so let's move on. But I hope you'll investigate these new things. What we want to talk about, however, is stuff that's GA, stuff that's already there in the code that you can use no problem, right? So I guess we can just put that in the background, go back to downloads directory, and shut that down. Okay, so what we want to do is we want to build a brand new application here at start.spring.io. And what we're going to do is we're going to build an application. Whoops. Don't save. Okay, we're going to build a brand new application that we're going to call Service. And this will be a reactive web application. It'll use RSocket. It'll use R2DBC, which is a SQL-based data access API. It'll use Lombok, and it'll use security, Spring Security. So it's just a very simple reactive HTTP and RSocket application that will talk to a database. And of course, we have to choose a database. So I'll use PostgreSQL because I have that running on my local machine. You can use Java 15, Java 11, or Java 8. Here you have 3 choices, but really, my friends, you've only got 2, right? It says 8, 11, and 15, but really, you can only choose 15 or 11, right? Java 8 is no longer supported. It's past its prime. It's old. It's deprecated. It's no longer a thing you should use. It's stinky. It's not fresh. Don't use it, right? So really, we've only got 2 versions to use. Java 11, which is the current long-term supported version of Java, or Java 15, which is the current 6-month version of Java, right? Every 6 months, they will update it and so on. So I can choose to use either one. Java 11's okay, it's fine, it's nice, but I love Java 15, right? Java 15 has text blocks and lots of other nice features that are just part of the language now. So I like Java 15. I'm very happy to use that. I'm going to hit generate, and that'll give me a service that I'm going to open up in my IDE. Let's see what happened here. Still going. What I'm going to do is open up the zip file. Okay. It's going to build everything. Alrighty. And all I'm going to do is I'm going to build an application using Java 15, please. Thank you. Okay. So it's a brand new application. And for the moment, we're going to comment out Spring Security. Obviously, you should never do this in production, but for our demo, we'll just comment out Spring Security because we don't need it yet. So goodbye, and goodbye, and goodbye, right? So I'm getting rid of all the Spring Security dependencies. Excuse me. What I want to do is I want to build a simple reactive application. So as always, I will start with my domain model. And the domain models, it's not very interesting. I just want to have something that will talk to a SQL database that will have a field called name and an ID or primary key called ID. Now, this is going to be using Spring Data R2DBC. And so I want to create I want to create an entity. I want the JSON. I want the constructors, all that kind of stuff. So I use Lombok. Lombok makes my work a little bit easier. And then I'm going to create a repository. I'll say reservation repository extends reactive CRUD repository managing reservations whose primary key is of type integer. Okay. Now, what I want to do is I want to write data to the database, and so here I'll create a sample data initializer, right? Initializer, yeah. And I'll just create a simple Spring listener that listens for the application ready event. And by the way, how do you say ready? Is it listo? Is it like in Spanish? No, maybe? Does that mean anything? Ready, right? So there you go. And what I want to do is I want to write data to the database. So I'm going to use that repository to write SQL records to the database here. And I don't have to actually implement that repository, of course. Spring Data will do that for me. I want to inject it via the constructor here. And here I can now write records to the database. So I'm going to create some names, var names equals. And by the way, again, Java 15, right? I can use text blocks. How cool is that? Like this. So I can say Ana, Maria, Paulo, and Bruno. There we go. Okay. So there's some names. And what I want to do is I want to take each name and split it, and then I can turn this into a, I'm going to map each one, right? I'll say map name.trim. And then for each one of these, I want to write it to the database, right? I want to write it to the database. So I need to turn it into a reactive stream, okay? So I've got an array. I want to turn it into a reactive stream that I'm going to write to the database. So I'll say var names stream equals flux.fromStream. So I'll say names. And what that gives me is a reactive stream of type flux. Flux is a reactive type from reactor. Reactor has two important types, flux and mono. Mono, I don't know if this is true in Portuguese, but in Spanish, mono means monkey. This is not a monkey. This is a type that produces data, but it produces no more than one record. Okay, so 0 or 1 record. That's very important. And then a flux produces 0, 1, 2, 5, a billion, a trillion, or infinite, right? It can go forever. These are both publishers, though, and they have lots of different useful APIs. APIs like combine, filter, map, flat map, all sorts of stuff. Look at that. If I scroll, it just goes on forever and ever and ever and ever and ever and ever, right? And ever and ever. There we go. So lots of code, right? 2,200 something lines of code. Trust me, you do not want to write this code. We have done the work for you. Thank goodness, too much work. This makes it easy to do all sorts of composition and data access logic in a very convenient way. So here I have a reactive stream, and what I want to do is I want to take each name and turn it into a new reservation. So null for that, and there's this. So now I have you can see that it's now a stream of reservation, not a stream of string, right? It's a flux of reservation. And then I want to take each one of those and I want to save the record to the database. I could try to do this. I could say this .reservation repository .save r. If I do this, however, what is the result of save? Well, save returns a mono. So that means I have a reactive stream. And what I get is I get a flux of mono, right? Flux mono of reservation. Well, I don't want 2 reactive streams. I want just 1. So you can take the inner reactive stream and make it the outer reactive stream by using flat map, right? And now I have just a flux of reservation. That's it. So now I've got data, and I want to write this data to the database. The problem, of course, is that this is a reactive stream. It comes from the reactive streams API. You can see that it's a flux. Flux is implement publisher, and publisher comes from the reactive streams API. Publishers have a very simple contract. The publisher has subscribers. The subscribers subscribe to the publisher. When the publisher has new data, it comes to the onNext method. When the publisher experiences an error, it comes to the onError method. And then the onComplete method is called when the publisher is done providing data to the subscribers. This bit right here, the subscription, is the most important part. This is what the subscriber uses to ask for more or less data from the publisher. So here the subscriber says, I want to ask for 10 more records, or 1,000, or whatever, 100, right? It doesn't matter. And this is what the subscriber uses to cancel the production, to ask for less data, not more, right? So this type is, it's very important, right, to have this subscription. This subscription means that the subscriber controls the speed at which it makes changes or consumes data. This is how the subscriber can say, no more, I don't want any more data, I'm done, right? That is called flow control. We've had one computer on the same network as another. That's flow control, right? Not a new idea. It's just that now it's part of the top-level Java API. This is very valuable in building more reliable systems, because now you cannot overwhelm a client or a consumer. You cannot denial of service them, right? I can also cancel the production. Instead of just slowing it down by requesting only 10 records at a time, I can also just say, I'm done. I don't want to do anything. Thank you. Bye. Right? I have the ability to push back. This is called back pressure, right? Or flow control. Same thing, right? It means the same thing basically. So these types give me the ability to build more interesting, more reliable services. But you can see that a big part of the API is that something must subscribe. Something has to subscribe in order for the subscribers to get the data. So here I have a publisher. I have a publisher of reservation, but I have not subscribed. And so nothing is going to happen yet. I need to subscribe. I need to say name stream.subscribe. And I can provide a new consumer, right? I can do that if I want. Or I can use the Reactive Streams one. I can use a new subscriber, right? Etc. I can do all these things. But I like the overload versions that come with Project Reactor. And some of these overloads are very convenient. So I'll just use this one and just print out the results. Okay. There's my stream. I'm gonna run it. Now the problem is, if I run this code right now, let's run it. Whoops. If I run this code right now, I need a database connection. And so I will say spring.r2dbc, r2dbc, Postgres, localhost, orders, username, orders, and then password. Okay, so there's my r2dbc connection string to my localhost Postgres database. I will restart it. Okay, and there's our data. You can see that it has worked, right? And if I go here, PSQL, view, orders, select all from reservation, right? There's the other names that were there. So let's delete it. Delete from reservation. Good. And you can see I've got a problem though, right? I'm returning the last 4 records that were written to the database. But if I run this program over and over and over, I will see the same 4 records written multiple times. So I want to first delete everything, then write everything, and then query everything, right? I want to get all 3 steps. So I want to use the API operators. I'll say first, this.repository.delete all, that returns a reactor mono of void. Then when that is done, then I want to write the stream of data. And then find all, okay? I want to print out the results. System out, print line. Okay. So now I'm actually forcing these things to execute one before the other. And this is important because remember, in a reactive application, this might happen on a different thread than this. And this might happen on a different thread than this. And so it's nice that I can use this API to say, even though this is potentially asynchronous, I want this to go first, and then this, and then this. I can guarantee deterministic order, right? And there's my record. So 1945, 1945, 1946, Maria, etc. Right? So very, very simple API. Okay, not a big deal. You could do this before. Let's create a simple HTTP endpoint, right? Very natural to want to do that. And you can use this. You can use the reservation You can use a REST controller, just like normal, right? You can say I want to create an endpoint. Reservations, publisher of reservation. I'm going to just inject the repository. So I'll say private final reservation repository. And here, I just want to return the record. So I can restart this. You can see it's just a regular Spring MVC endpoint, nothing special, right? It's just got a class that I've injected into the constructor. It's a REST controller, and if I go to the browser, localhost 8080/reservations. Oh, I have Spring Security still, do I? I thought I got rid of it. Did I not? Don't need this. Did I forget to do this? Okay, restart. Okay, good. So that's no longer there. Reservations. There's our data. Okay, so I have a very simple HTTP endpoint. I have my JSON data, and I can hear you say, who cares? Of course, it's just JSON. It's just 4 records. It's not a big deal, right? You could talk to a Postgres database yesterday. You could create an HTTP endpoint without reactive APIs yesterday. There's no reason, you might think, to use what I'm showing you. And that's true. What you're saying is correct, but I'm not trying to show you something brand new right now. What I'm trying to show you is something that you could already do, that you can do just as easily with reactive APIs. The code is not more complex, even though this is much more efficient. You can't really see the difference in terms of the lines of code. There is no difference, really. It's actually a very simple, very clean API. And if you look at what we have done here, look at the code that we've written that's actually business logic, right? We've got, we don't need this initializer because that's not real business logic. That's not going to be in production, right? So really, all you have is a REST controller, an interface, and a DTO, right? That's the only business logic, and that's how you build a reactive application. Very, very succinct. Now, I can make it more succinct, right? See this REST controller? It's a long-form version of an HTTP API, but there's also a nice alternative style called functional reactive endpoints. Server response routes router .build /reservations. And here I'm going to inject my reservation repository request .ok.body rr.findAll reservation.class. Okay, so you can restart this. Okay, refresh. And now it's the same API, right? But I've written the code in much less lines of code. I no longer have all of this stuff. So it's either, you can do both actually. As long as they are not mapped to the same HTTP endpoint, then either one will work just fine, the REST controller or the functional reactive style. But either way, it's not a lot of code. That's what is important, right? It's very simple to do. And I think that in this case, it's such a simple example that of course it's very little code. But what you will find is that when you get to more complicated examples, by using reactive APIs, you're actually getting more consistency. You're getting more uniformity. So if you want to do HTTP JSON, then you create a publisher. If you want to do WebSockets, you create a publisher. You want to do Kafka, you use a publisher. Do you want to do RabbitMQ, you use a publisher. Do you want to do server sent events, you use a publisher. You want to do RSockets, you use a publisher. Do you see what I'm saying? It's just one thing now, one kind of API. It's no longer the case that you have a dozen different APIs to do different things. Now, if you want to describe data that is eventual, it's asynchronous, it will be here in the future, you just use a publisher. And it's the same mental model. And because everything is just a publisher, now it's much easier to compose different services, to glue them together, to make them do things together in ways that was very difficult before. Kafka has a different API than JMS. which has a different API than RabbitMQ, which has a different API than WebSockets, which has a different API than server-sent events, which has a different API than regular application JSON or XML or something like that. Every API was different because there were different ways of describing, here's data, it's not here right now, it'll be here in the future. It might be fast, it might be slow. It's asynchronous, right? How many different ways do you know to do that? And how many different threading models do you have to learn to do that? Now, with reactive streams, you've got one, just one. And so this is where I think you really start to get some value out of using reactive APIs, is consistency. You get consistency. You can glue things together. The other place where you get benefits out of reactive APIs is in the resource efficiency. And so you've seen me use these reactive APIs. I guess, where did I use it? Down here, right? I created a reactive API. It's like using the Java 8 Streams API. It's not hard to understand. There's not a lot of stuff going on there. It's just reactive streams, right? And it's kind of like the Java 8 Streams API. So I love that about it, right? I love the consistency there. But it's also the most efficient version of this code, right? And to really understand what I mean, let's create a new endpoint, okay? Let's create another endpoint here. Class greetings service. And this service will produce a stream of responses if you give it a request, okay? So I want to say private string message, data, no args, all args, okay? Good. Good. So I'm going to take these and to this, and the request will have a name. So, okay, so message and name. These are the request parameters and the responses for our little service that we're going to build here. So at service. And what I want to do is I want to create an endpoint that will produce many results over time. Okay, so I'll say greetings response, greetings request. Okay. Say return flux.fromStream, stream.generate, new supplier, new supplier. Okay, well, that's what happened here. Whoa. Bye. New greetings response. Hola. Request dot get name at instant dot now. Okay, so there's my reactive stream, and I want to slow it down. First I'm going to just take like, let's say I'll take 100. Okay, I'm going to keep 100 of them, and then I want to delay the elements. I want to delay the production of the data. Okay, so I'll say duration of seconds, 1 second. Okay, so I want to use that to produce a stream of responses that somebody can use. Well, how would I communicate this data to the client, right? How would I send this long stream of data over time? I can't really use application JSON, right? Because JSON it's all at once, right? You get the whole document. It doesn't really stream very well. I could use WebSockets, and that's not very difficult to do. You can do that. But what I want is some way of communicating data that I can consume as a service, right? And remember, I do have time. I have this asynchronous time in my API. So my whatever protocol I use has to be asynchronous. I can't use application JSON, like I said. This time, by the way, this introduction of time is possible because behind the scenes, Reactive Spring is using something called a reactor. And reactor has this concept of a scheduler. And so you can see that the scheduler is there in everything that you do. You don't normally need to worry about it, but you can if you want. You can say, for example, I want to subscribe on a particular scheduler, right? I can say from an executor or whatever, right? I can do that. You can do all sorts of interesting things. You can subscribe on to different schedulers. There's a bunch of them that are provided for you out of the box. You don't really need to worry about it though, right? If you want something that executes synchronously on the same thread as the client, you can say immediate. If you want, the a single thread, you can use that. If you want a parallel thread pool, you can do that. There's just lots of really useful ones, right? So it's very useful. But you shouldn't need to worry about that. You only worry about that if you're talking to some other thing that is not reactive, some other API that does not have these reactive streams types. And so you want to integrate them, and you know that you must block, you must do work on the thread, and you cannot get off the thread quick enough, right? And this is undesirable. We don't want to spend too much time on our threads. So reactive APIs have this idea of a scheduler, and the idea is that everything you do on that thread has to be non-blocking. So that means that you don't waste time on the CPU, and it means that you don't keep the thread if you're not using it. If you're sitting there just waiting for bytes to arrive over the network, then you're wasting a thread. If you're sitting there just doing cryptography, you're using the CPU to do Fibonacci or Bitcoin mining or something like this, then you're using the thread and nobody else can use it, right? Sometimes, like with security, there's no way to fix it, right? You have to have security, and so you have to waste time on the thread. But at least make sure to move all of that thread work into a separate scheduler. That way, the other work in the system can all use the non-blocking thread pool, the non-blocking scheduler. And if you have code and you find that you are running out of threads, that your system is starved for threads, then that means that you've done something on a thread somewhere that is blocking. You need to not block. And so to help you find where you might be blocking, we have a very nice Java agent that you can use called blockhound. And this blockhound is just a very simple API. You add it to the build path of your code, and you do blockhound.install. There's a Spring Boot starter, so you don't even really need to do that. And then inside of a reactive stream like this one, Mono, right? It's a Mono reactive stream. Inside of that, you can do something like thread.sleep, which blocks the thread, right? And if you do that, the blockhound Java agent will detect it and throw an exception. It'll show you where you are blocking your code, which is causing trouble, right? So you shouldn't need to modify that, but you can. So we have a service now, and we want to make the service available to other things in the system. We want other parts of the system to be able to use this service. Like I said, we could use WebSockets, but you don't really use WebSockets for service-to-service communication. That's not really a great fit. Most people use it from the browser. And WebSockets are not a good fit for service-to-service communication anyway. They don't have certain things like headers, HTTP headers, right? So this is a problem. This is a very, very big problem. So what we want is some sort of protocol that allows us to communicate quickly, efficiently, that is more flexible than HTTP, which only supports request response. We also want something that gives us more flexibility in terms of how we communicate data, right? So we cannot use gRPC because it's only Google protocol buffs. gRPC is Google protocol buffs plus a RPC header, right? We don't want to be stuck with text either. Binary data is good, so we don't want to use regular HTTP 1.0. We want multiplexing, so we can handle multiple transactions at the same time. And we also want something that is operations friendly and back pressure aware, reactive in nature, right? So gRPC is not reactive, it's asynchronous, but it doesn't understand the ideas of back pressure very well. So in order to use it, in order to do that, we have to kind of get around it, right? HTTP doesn't understand back pressure either, right? Think about what happens with our HTTP endpoint that I showed you earlier. Imagine that endpoint was returning 1 billion objects, right? Just streaming the data for like minutes, right? Just lots of data. And the consumer is reading the data, but then the consumer says, okay, no more. Well, with HTTP, it's not possible to just stop and then come back an hour later and pick up in the middle where you left off. The only thing you can do is cancel, right? And that means that the next time you have to start again. So you can't really do session resumption like you can in the Reactive Streams APIs. The best thing that we can do from a reactive web application is to just cancel, right? The client disconnects, and then the reactive server, Spring Web Flux, our reactive service, it notices, it sees the client has disconnected, and it cancels the reactive stream to allow the client to disconnect and to stop any more data from being sent, because we don't want to send all that data if there's nobody there listening or reading it, right? So we want something that gets around all these limitations. And so my favorite thing to use these days is something called RSocket, right? So what I want to do is I'm going to use RSocket here, and we're going to build a client to talk to our asynchronous service. Okay, so let's say add controller class RSocket greetings controller, right? We're just greetings controller. Okay, and here the greetings controller is going to need our greeting service. So greeting service, require args constructor, and we're going to create an endpoint that uses RSocket, this binary protocol, to return all the data, greeting response. Oops. Greetings request. Okay. Return this greetings request, greet request, and voila. Okay, so there's our endpoint. Okay, very simple RSocket endpoint. And in order for this to work, I need to tell Spring Boot to create an RSocket port. And I'll say 8888. So now I have an HTTP service and an RSocket service. Now, you have to understand that RSocket is an open source binary protocol. It was developed by engineers at Netflix and at Facebook. It has support for 4 different message exchange patterns. So single value in, single value out, that's called a request response. I can have a single value here, and I can have multiple values over here. That's called a request stream. I can do a single value here and nothing in response. That's called fire and forget. And then I can also have multiple values here and multiple values here. That's called channel. So multiple values coming in response, I get multiple values going out, right? So those 4 message exchange patterns are much more flexible than the defaults that you get with HTTP. The other thing that's really nice about RSocket is that it's truly bidirectional. So I can have one side talking to the other, and the other one can start talking to the other at any time. Once 2 computers are connected using RSocket, they are not client and service. They're more requester-responder. But the responder can become a requester, and the requester can become a responder at any time. It's not, they can both do both things. And so it's not really appropriate to say client service anymore. It doesn't exist. That's a thing that we are thinking about from HTTP, but it does not have to be the way that we think about our RSocket services. The other thing that's really nice about RSocket is that it was designed for production. And so when I say designed for production, remember, it was built by Netflix and Facebook, right? It's been used in some of the largest websites on the planet. Indeed, another company, Alibaba, they're a company in China. Everything is Spring at Alibaba, all Spring, and lots of Spring and Reactive, and now RSocket. I introduced them to RSocket a couple of years ago. And now, thanks to the community effort and so on, Alibaba is part of the Reactive Foundation, along with Facebook and along with the Spring team, of course. And the first project that we put there was RSocket, right? So this RSocket is the first project of the Reactive Foundation. And it's something that we're all working on together to make it so that there's this really powerful way for organizations to build services that are flexible, robust, operations-friendly, secure, payload agnostic, etc. So I have now my service, and I want to build a client. And let's talk about this. We're going to build a client, and we're going to talk to our API from RSocket and from HTTP. So we're going to use the reactive web support. We use Lombok. We use RSocket. We use Spring Security. And we build a client, right? I'm happy with that. Hit generate. Now, I could build a Java client to talk to the API, and that's what we'll do to talk to the RSocket service. One thing that you might want to do is to talk to that service using a command line utility. And there's something called RSC. RSC is an RSocket client. It's a command line utility that was built by Toshiaki Maki in Tokyo. He is he works with me and at VMware at Tanzu, and it's awesome. It's just a very convenient utility. So you can say, I want to send a stream request to to an endpoint, and I can provide the payload of the endpoint. So like so. Josh, right? And the name will be Josh. And the endpoint will be TCP localhost 8888. Okay. So I'm sending data in, no handler for exception. Did I not start this up? What port? 8888. Oh, I forgot to specify the route, right? R greetings. So there's my data. You can see I'll get new data. I'll get 100 records. It'll keep going, and then it will stop, right? But it's going to take 1 second each, so it'll take 100 seconds to get me all the data. And that's okay. It's being sent over the wire using this binary protocol. But behind the scenes, in between each new message, the thread is free. Something in the system can use the thread to handle other requests. So we're not keeping the thread for all 100 seconds. We're keeping it for just a small time it takes to send out the next result and then move on to other work. This is how we get really efficient systems and scale. Now we can handle many, 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 many more transactions using reactive APIs, right? That's one of the big wins, is that now the cost of handling so many users goes down dramatically, right? Okay, so I can use this. I can use RSC. It's a nice command line utility, but I want to build an actual client. So what I will do, I'll go here and open up the client.zip. Okay. So here's my application. And this application is going to talk to the other application using HTTP and RSocket. So let's look at HTTP first, okay? What I want to do is actually, what I want to do is I want to build a bean of type web client. In order to do this, I'll inject this. I'll say builder.build. And I now want to build a bean that injects that. I'll say application listener, application ready event, ready, turn event. Okay. And now I've got the web client. So I'll say HTTP. And I want to call the other service. And here we get some benefits. Remember, this is a non-blocking HTTP client. So I can make as many requests as I want on the wire, and it'll be okay, right? I won't block the thread on the client either. So I can say get URI HTTP localhost 8080 / greetings. Oh, reservations. That's the reservations endpoint, right? And I want to take the data from here. I'm going to take the DTO, the client-side representation of the data. I'll take this. Okay, we don't need that. I'll take the greetings request and response. Good. Take this and that. Good. So there's my basic DTO with my client-side representation. And what I'm going to do is I want to use these reactive streams to call, I want to use these reactive clients to call the other service. So we'll say retrieve the data, and then the body data that comes back will be of type reservation. And so if you look at the result, what I have here is a reactive stream of type reservation, right? There's the whole thing. So that's the entire call to the downstream service. But of course, I have not subscribed yet. So if I want to read the data, then I actually have to subscribe. I can say .subscribe, like so, and I can print out the results and do what I want with them, right? No problem. But I've already, I'm making a network call. I'm using HTTP. I'm using the HTTP client. I'm calling a single host and port. What if something goes wrong? Well, I can retry. 10 times. I can retry when back off is required. Duration of seconds, 1, right? I can do all sorts of things to make sure that my service is more reliable. I can also specify a timeout, right? I can say timeout of seconds 100 seconds, which is insane, right? But just imagine. I can also do an error handler. I can say, okay, when there's an error, when there's a illegal, whatever, right? It doesn't matter what error, but when there's this error, then I want to return a custom stream. In this case, I'm returning an empty stream. So I can control how I make these calls across the network, and the result is still just a reservation publisher. It's just a stream of reservations. I don't have to do anything special to make that work, right? It just is. And so now I can use a circuit breaker if I want, right? There's Resilience for J, which has a reactive circuit breaker, and it has a reactive rate limiter, and it has a reactive bulkhead and all that stuff. I can use that. But again, it's just so nice that most of this is just built into Reactor now, right? I don't need to use Spring Retry. I don't have to use Spring Cloud Circuit Breaker. I don't have to use a lot of stuff here, right? I don't have to use Hystrix or anything like that. It's just all built in now. Okay, so what if something still goes wrong? What if I've retried it 10 times and I've waited 100 seconds and I've provided a default value and something still goes wrong? My user isn't going to get the response that they're expecting. I have an SLA, usually you have SLAs. When I call the other service, I want to make sure that I get a response in time. And so one pattern that people often use is to call the same service on multiple hosts and ports. So host 1, host 2, host 3, etc. And in this way, they get one response quick, right? Maybe one is slow. Maybe it takes forever to get the response. But not all of them are going to be slow. Only one, or maybe two, right? But one of them will also be fast. And so you'll get your response in time. This is much better than a timeout. With a timeout, you must wait however long, then you try again. And hopefully, if your client is expecting you to produce a response in, let's say, 10 seconds, that means that you must get the data that you need from some other service within 5 seconds. And that service needs to get the data that it needs in 2.5 seconds. Because if it fails the first time, then it can retry one more time, right? So if you have an SLA of 10, you try in 5. If it fails, you try again. You still fit in 10 seconds, right? Same thing for everything after you. But the problem is that this does not scale, right? The further away that you are from the origin of the request, the less time that you have. It decays very quickly. And so instead of doing this, it's much more natural to say, I want to ask 3 different services for the same data. I don't care which one gives me the response first. Everything else I will ignore. But I want to keep the first one. So imagine writing this code using regular threaded Java. You'll create 3 threads. You'll make the network call. And then as soon as something produces bytes, you'll have a cyclic barrier or a countdown latch, and you'll trigger that, and then you'll force all of them to converge, and you'll return that. That would not be easy or fun or even understandable code to write. But in the reactive world, this kind of stuff is very easy. Because remember, in the reactive world, threading is done for you. It's very important at this point to highlight something very, very useful, which is nobody knows how to write truly effective, reliable, multi-threaded Java code, or at least only one person knows how to write truly effective, reliable, multi-threaded Java code. Only one person, and it's not you. It's not me either. It does not matter who it is. Nobody knows who it is. But the point is, threading in Java is not to be trusted. So if you can let the framework do it, please do. So what I'm going to do is I'm going to write this code as an example. Okay, let's say I call the first host 1, host 2, and host 3. Okay, and I'm getting the same. I'm making the same data request. Right? Imagine I'm doing this 3 times, except here I'm doing host 1, host 2, host 3. Okay, so now I've got 3 different reactive streams. But notice that I have not subscribed. Right? So I've defined the pipeline. I've defined how the stages of data fit together, but I have not defined how they get returned. Right? I have not actually turned on the faucet for the water. Right? I've defined the pipes that connect and keep the water flowing, but I haven't turned on the water. So there is no water in these pipes yet. Now, what I want to do is I want to say, whichever is the fastest, I want to keep that. Well, again, very easy to do this using reactive APIs. See? I just say flux.first, host 1, 2, 3. And it'll automatically keep the fastest and it'll apply back pressure. Now, of course, in this case, I'm making 3 network requests, right, at the same time. they're all being launched at the exact same time. And that might be a problem because I'm making the same request 3 times. So this only works for idempotent endpoints, right? Idempotent, right? You should never use this on the charge the customer credit card endpoint, right? Don't use it for that. They won't like it. Use it for things where you can get this, you can make the same request multiple times and not have any undue observable side effects. So this is a very natural pattern that I've just described to you. It's called hedging. Hedging, right? So I'm hedging my bet. You know, they say don't put all your money on one stock in the market, right? Or don't put all of your eggs in one basket, they say. Same thing here. We're not going to trust one host to provide a response since we need the response to be guaranteed. So you hedge your bet, is what we say in English, to guarantee that something works in time. So hedging is one thing you can do. The benefit of reactive APIs is that it's very natural to do scatter, gather, service orchestration, and composition, okay? So let's imagine that I have a reactive stream, let's say class here, class order, private, just the string customer ID, okay? And let's say I have class customer, and I have a collection or list even of orders. And okay, these are just 2 types that I've defined, and I want to create a final. These are my 2 types, and what I want to do is this data. I will get back. You know what? Actually, I want the customer data. Actually, I just want the customer data. So final string ID name. Okay, and then I want to have an aggregate. So this is going to come from the customer service. Okay, and this will come from the order service. So I have these 2 different types. What I want to do is I want to call the customer service, get all of the customers, and then I want to call the order service and get all of the orders. So imagine I have like a CRM client, right? Interfacing. Actually, let me move all of this here, right? And so now I have an interface for a CRM client, and the client gives me different endpoints, right? So publisher of order, get orders by customer ID, string customer ID, okay? And then publisher of customer, get customers. So what I want to do is I want to call this microservice, and I get the reactive data back from there. And then for each one of these, I want to get all of the orders from this microservice. And I want to compose them together into one aggregation called customer orders, right? Final customer, final list orders. Okay, so just creating an example here, right? Required args constructor. There we go. And so now I want to actually create this code. So how would I write this code in a reactive way? Well, let's say I have an instance of the client, right? I'll just, whatever, we won't implement it. I just want you to kind of see the patterns that are possible. So now I'm going to say, give me all the customers, okay? And what I want to do is I want to visit each customer, say for each customer, map into a tuple, right? So I'm going to say flux.zip mono.just c. I've got a mono, it's a reactive stream there, and the next thing I want is to call CRM client dot get orders by customer ID. So c.id, right? So now look what I get. If I do this map, I've turned each element, I've turned each customer into a reactive stream, right? Like that. And what I have is a publisher. I'm going to do flat map. Look at that, flat map. There you go. So I've got a reactive stream of a tuple which has 2 items, customer an order, but I don't want each individual order. That's a one to n to y relationship. So what I want to do is I want to get the orders and I want to turn it into a list. Now, if I look at this, that's what I have. I have a stream of tuples of customer of list. So now I can visit each one. Okay. And what I'll do is I'll say, okay, let's visit each one. I'll say tuple to flux dot map tuple new customer orders tuple dot get T1, that's the customer, tuple get T2, that's the list. And now I have a stream of customer orders. And so this is very easy to write. It's very easy to understand what's happening here. But behind the scenes, since these are, we have not implemented this, right? This is a to-do. But since this is just a reactive API, and since I could be using this, the reactive web client, then the network calls that I'm making to get the customers and to get the orders and all that stuff, these are network calls that are happening at the same time. It's doing all the threading for us concurrently. It's super, super fast, right? I'm making as many requests as I can at the same time, and as they start to come back, I put together the stream of the response. I'm not waiting for everything to come back. As each record arrives, this flat map gets invoked, and I create this tuple, and then I create the customer orders aggregate, right? So it's streaming the results back all at the same time. This is very efficient. This is much easier than having to write multi-threaded Java code with, call this service and call this service and then wait for the results and all that. It's very natural to express it like this. So using reactive APIs makes life easier when you're doing service orchestration and composition. Very useful in a microservices world. You can see it's easier to combine reactive streams. It's also easier to make the streams more reliable, right? It's just built in. This is all just Reactor. There's nothing that's magic about Spring here or anything. It's just Reactor. The reactive web client that we can use, that's coming from Spring. But all of these APIs I just showed you, the map, the flat map, the on arrow resume, retry, all of that is just part of Reactor, right? And this is why when Facebook built the Java client for RSocket, this binary protocol that we've been looking at, they used Reactor to build that client. And so as a result, as you've seen, it's very easy for us to build smart APIs using Reactor out of the box. I don't have to do anything special to make that work. Right? That's already there. Now, going a step further, we can use RSocket to talk to that other service. We can build an RSocket client instead of an HTTP client, right? This is HTTP client. Right? And let's get rid of that. We don't need all of this anymore. That was just a demo. We don't need this. We don't need that. Don't need this or that, okay? Now, we have just our and you know what? We don't even need this. Actually, let's just get rid of all of that. We've seen HTTP. That works just fine. Now let's look at RSocket. Okay. So I have now just the greetings request and the response. I don't need the reservation anymore. Goodbye. So greetings request, response. And let's create an RSocket client instead. So here, I'll create an RSocket requester. Not builder. And here, when the application first starts up, it'll connect to the RSocket service, and it'll stay connected. This gets done at the very beginning of the application. It doesn't have to wait for each application. It doesn't have to wait for each transaction. So with HTTP, if I want to talk to that service over there, I make a call to that service over there, and then I do a handshake, and then all that stuff, and I have to wait for the response. With RSocket, you connect once. Once you're connected, you can reuse the same connection for lots and lots of transactions at the same time. Okay, it's multiplexed. This makes it more efficient. You don't have to do the constant network handshake. So what I want to do is I want to now make an RSocket client. So I'll use this. I'll say application listener, application ready event, RSocket. Okay, and what I'm going to do is I'm going to make a call, requester dot route greetings, and I'm not going to send any data in except for the request, right? So I'll say a new greetings request, and I'll say Okay. And I'm going to expect a stream of responses back. Right? I'm making a reactive stream to the service, and I'm getting a stream of responses back. But again, it's just a reactive stream. It's a publisher. So as before, I can do, just like with the HTTP, I can do retries, I can do backoff, I can do all this stuff, right? It's just a stream, okay? And now I can print the result. I can say subscribe, system out, fine. Try this. Oh, wrong port. I'm not using HTTP anymore. So, I will just remove this. Okay. That's the other problem. Now that there's no HTTP server, and since there is no RSocket server, the program starts, there's nothing to do, and then it stops. And it stops too quickly. Remember, this is asynchronous. So the program started and didn't stay running. So I have to block the thread somehow. And there we go. There's our RSocket client getting reactive streams over the wire forever and ever and ever. So this is very natural, right? I'm making a request from the client to the service, and I'm getting back a reactive stream, and I'm not blocking in the client, I'm not blocking in the service. Life is good. Now, I have a reactive stream here, but remember I told you earlier that you can do bi-directional communication, right? You can actually have the client provide a controller of its own for the service to ask questions of, right? Either side, this side and this side, can ask questions of either side at any time. So what I'm going to do is I want to change my RSocket requester here to have a RSocket connector, a config, and I'll provide an acceptor. So it's a bean type socket acceptor. And I'm going to say RSocket message handler responder. So I need to provide a little bit of information to the RSocket message handler to understand the encoding and all the common strategies that we're using to do conversions and encoding and all this stuff with RSocket. And so in Spring Boot automatically creates this called an RSocket strategies. You will use this a lot. You'll see that RSocket strategies is used in a lot of different places. So it's very useful to just inject it. And here, I'm going to provide my own controller. Now, what I want to do is I want to provide let's say that my client has like a heartbeat, boom, 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 boom. And I want the heartbeat to be created every second, right? Every second. And I want the client, or rather I want the service to see the heartbeat from the client. And if the client says it's healthy, then the service will continue to give data to the client. But if the client says, oh, I'm busy or I'm sick or whatever, then the service will stop working because it should not waste any extra time, right? You can imagine lots of examples where it's useful for the client and the service to talk to each other all the time, right? Maybe you have presence notifications, like I've stepped away from my keyboard, or I'm no longer at my desk, or out of office notifications, or stock trading kinds of things, right? All sorts of interesting things where it's useful to have bi-directional communication. So I'm going to create a controller endpoint here. But remember, we're in the client. I'm creating a controller in the client that my service will talk to, right? So this is it's going to be both a requester and a responder. So we'll say client health state controller, message mapping, health controller, publisher of client health state, turn flux.from stream.generate, the supplier. Okay. And I want to delay this as well. I'll just delay it by 1 second, just as before. And what we're going to do is we're going to return a new client health state. We're going to say that for most of the time, for most of the time, it's healthy, right? So as long as math.random is less than 0.8, right, which means that there's an almost 80% chance, there you go, 80% chance of it being healthy. If it's not less than 0.8, then it's in the 20% chance that it's not healthy. And as soon as it's not healthy, we want the client to disconnect, right? It'll stop sending data. We want the other side, not the client, the service, the greetings endpoint. We want that to stop streaming data. So this is our client health state controller. And I'm going to inject that here. I'll say, okay, let's put that in here. Health state controller. Alrighty. Up here. Good. So now we just need this thing here. Socket acceptor. And there we go. Okay. So I'm creating my RSocket requester, but I'm also exporting an RSocket endpoint so that the other side can ask me questions now instead of me just asking it questions. So this is the client. Before we can run the client, we need to change our service now, right? The service must know about this health endpoint. It needs to do something with this information. So we'll take this DTO, we'll paste it here, and what we will do is we're going to change our code so that when the client connects to our RSocket endpoint, we can take the data that's coming in and use that to ask questions. So we can say, okay, first of all, this is the greetings, right? We've got the greetings. And we also want to get a hold of the socket representing the incoming RSocket request. So client RSocket connection, okay? And we can use that. We can say, okay, client dot route healthy or health, and then we're going to expect a stream of data back, client health state.class. Okay, I have a reactive stream of client health state. Now the thing is, I don't want every single instance of the health. I only want the health when there's something unhealthy, right? I don't care if it's healthy. If it's healthy, then who cares? I don't, just keep going, right? But if it's not healthy, then I want to stop what I'm doing. So what I will do is I will filter out the healthy health states and keep only the unhealthy ones. So the filter means that this stream will be empty most of the time. There'll be nothing in it because it will be dropped. Every time it goes to the filter will drop those records and there's nothing there. Unless the service is unhealthy, in which case we'll have one record, right? So what I want to say is take a greetings response as long as there is nothing in this reactive stream, as long as this is empty. If it's empty, then keep sending the greetings. If it's not empty, then stop sending the greetings, right? So it's a very interesting kind of multi-threaded, concurrent kind of operation. I want to do this while this, right? But it's also network kind of thing. Well, now it's very easy to do that. I can say, okay, greet, take, until, other, right? Very natural. Yet another example of where these operators make it very easy to express very complex things. So now I've got this here. Let's try out by restarting the service. And on the client, we'll start up again as well. Okay, we got one record. So I guess we got unlucky very quickly. Let's see. Do we have anything else we want to see there? I guess that's it. That'll do it, actually. We've got the greetings required. Okay, so there you go. That's basically an example of where we are showing that this thing is becoming unhealthy. So let's restart the client again and see if we can get maybe more this time. Maybe 2 records or 3 records or something. No. Oh well. Okay. So this is one thing that we can do, right? Is to slow down the response in this way. Okay. Now the other thing that I want to do is I want to secure my applications. I've got two sides. I've got the client and the service. I want them to be secure, and we have 6 more minutes. So I want to use Spring Security to lock this down. Okay. So what I will do is I'll go to my build. I'm going to reactivate this and this. Okay. Good. So now there's this. Now what I want to do is I need to configure authentication and authorization. So in my service, I'm going to create 2 very simple in-memory configurations for authentication and authorization. So at bean map reactive user details service, authentication, return new map reactive user details, user.with default user details, default password encoder dot build, and I want to create a username, a password, PW, and a role user. Okay, so there's the entirety of that, and then I want to configure how I can reject invalid clients, or which parts of the API are secured. Right, some may be open to everybody, and some might be only available to certain things. Right, so payload, socket, acceptor, interceptor. This is authorization. So I'm going to say that in order to configure this, I'll use the RSocket security DSL. Hello. Socket security dot build, and I'm going to say I want to authorize the payload. I want to authorize nothing basically. So any exchange needs to be authenticated. Everything will be authenticated. Everything is locked down. And I could use JWT, but I don't want to set up all of that right now. So I'll just use regular simple authentication, which is just usernames and passwords. Now, the other thing is, now that I've done this, I can also change my API here a little bit. Let's change this just a little bit, okay? So what I'm going to do now is that instead of using this, what I'll do is I'll expect an authenticated principal of mono of user details, okay? So that's my current authenticated user provided by Spring Security. And I want to say user dot map user details, username, map name, new greetings request, passing in the name. I take that, gr, I'm going to call this .greet, passing in the client RSocket connection, and then pass in gr. So I'm calling the original one here. What does this do? Greetings request. What's the issue here? Oh, flatmap mini. Yes, of course. Okay, so there's my new call. Updated. Alrighty. So there's the entire API, right? There's the simpler API. But now this other endpoint that I had before, it's just an implementation detail, so I can make it private and hide it, right? So what I'm doing is I'm injecting the current user. In order to allow this annotation to work, we need to register a bean. We need to register the RSocket strategies customizer, I think. X. No, we want to do an RSocket message handler. So R. What am I doing here? That's the it's a CRC, right? New R C RMH equals RMH.get resolver, add new simple authentication. What? I build RSocket, Spring Security Messaging. Where did I've got security, I've got messaging, I've got web flux. Start security. So this type it's looking for is a handler method argument resolver. So usually IntelliJ just gives me the prompt, but simple, wrong one. Okay, new of these. And we just want to open up this one. We want to see the types. Simple. Am I missing something obvious here? Go cheat, my friend. We have no time. So github.com, Josh Long, RSocket Revolution. And we are in the service application. Okay. Right there, right? RSocket message handler. Add custom result. Yeah, I did the same thing. Whatever. See, okay, let's see what that gives me. We want to use this one, maybe. There you go. So that's the connection for the RSocket message handler. All that does, usually I just control space, and IntelliJ has seen me type this before, and it's no problem. But I just upgraded to the new IntelliJ. Now it's confused, and I'm confused. I'm sorry about that. So okay, let's go ahead and restart this service. And now on the client, we need to connect to that service, which means that we have to authenticate, right? So it's compiling itself on there. It's going to restart on the service. Good. Now in the client, I need to connect to the service in an authenticated fashion. And so authentication is done using metadata. Metadata is kind of like message headers. And it's kind of like messaging headers in other technologies and other protocols. The difference is that here, metadata is a MIME type matched to a string. So I say MIME type, right? MIME type equals MIME type utils, well-known MIME type, dot authentication, Activiti Spring, and private final credential, right? Private final username, password metadata, creds equals new username, password metadata. So it'll just be JLong and PW. Okay. That's what I'm going to use to authenticate. In order to do that, though, I need to teach RSocket to look for that kind of header and to send that header in the data. So I say I'm going to create an RSocket strategies customizer here, new RSocket strategies customizer, and in the customizer, I'll use strategies, and I'll say strategies.encoders is new simple authentication encoder. Right? There's that. And once I've done this, I need to actually either send the encoding when I create the art socket requester, so I can do that here, like this, set up metadata, this dot creds, this dot MIME type, right? That's one place I can do it. Or I can do it on each transaction. Right? So I can do this dot metadata, etc. Okay. Either way is fine. If you do it once per setup, then you should not share the connection with other users. If you do it per transaction, then you can share it for as many users as you want, right? So let's see now. There we go. Hola, J Long. We got a response back. All right, my friends. We have looked at just a few things. It's only been 94 minutes. I hope that you learned something new here today. I hope that you had some fun. I want to thank you for being here. Obviously, obrigado. I appreciate it. I hope that we get to meet again one day. I'm happy now to answer questions. Thank you for your time, and stay safe, stay healthy.
Yeah, I have a couple questions for you.
Of course.
The first one is Spring indicated to return a large numbers of images from the back end to the front end?
Say that again.
Is the Spring reactive to return a large number of images from the back end to the front end?
Images, like binary data?
Yeah. Yep, exactly.
Yeah, I guess so. Why not, right? I don't know how you would do that, though. I guess you could.
Okay.
I mean, if you can code it with asynchronous I/O, then you can describe it using reactive APIs. So behind the scene, like for binary data, you end up using things like byte buffers in Netty, which is fun.
Should work like a streaming video or something like that.
Well, you can do so, like RSocket. I guess you could do streaming video, but I don't know if somebody's done that. Okay. It seems theoretically possible, but I don't know. I'm sorry.
George is asked that I really like checked exceptions, and I believe that it gives expressiveness to Java reactivity things towards runtime exceptions. What is the best way to mix checked and runtime exceptions with Reactive Spring?
So in reactive APIs, because you're not using, the try catch doesn't make any sense anymore, right? It doesn't make sense because try catch is one thread. It happens in the same thread. You throw an exception and there's a control jump down to later on in the same thread. But now errors might happen on any of a number of different threads. So in Reactor, you have the on error callbacks that I showed you. On error, resume, on error, continue, etc. That's how you would handle exceptions. And that's good because you can actually ask Reactor for what's called an assembly trace, not just a stack trace. Stack trace is just one thread. An assembly trace shows you the trace across multiple threads all in one place, right? And that can give you a lot more insight into what's happening. So try catch is no longer, it's not your friend anymore, right? Like you need to think about more functional style error handling.
Okay. Leonardo Segala asked interactive programming with Spring Boot is more difficult to bring your API environment more like this. Okay. In the reactive programming with Spring Boot, it's more difficulty to bring your API in a cloud environment more, for example, more resilient or the positive. If you
more resilient or more difficult?
Yeah, exactly. If it's more difficult or not.
No, I think building reactive APIs is. Let me try this again. If you're building new software today, I would only use reactive APIs. You're wasting money if you don't use reactive APIs. The code is more difficult. It scales poorly. If you're not using reactive APIs, it's more difficult to code. It's scaling poorly, it wastes your data center spend bills, and also it's less robust. So I think it's, I cannot imagine not using reactive APIs now. Now that I finally understand it, I'm like, oh, okay, that's way better. And I feel a little embarrassed that it took so long to learn. Like I've understood concurrency for many years, but only in the last 10 years have I learned about reactive programming, right? That's a new thing for me. And even more interesting, right, is a lot of other languages have built things kind of like reactive APIs, right? And so if you look at JavaScript, for example, they have the promise API, right? In Python, they had futures. But those were not quite the same as reactive because they didn't understand multiple values, right? So 1 value, 2 values, 5 values. 1 value, that's fine. That's a completable future in Java, right? But what about 1,000 values or 1,000,000 values or infinite values? This is where the reactive streams types are very useful. If you understand these reactive APIs and you understand what's happening behind the scenes, however, and if you understand asynchronous programming using these APIs, then you're in a really good position because now if you use something like Kotlin, Kotlin provides a DSL and you can automatically use coroutines with reactive APIs. So now you get, code that looks like it's imperative code, but behind the scenes, you're actually using very efficient, very scalable reactive APIs, right? So now you get the best of both worlds. You can learn reactive APIs, but you can also write code that looks like it's synchronous blocking code. And this is, Kotlin is very good. It has a nice keyword called suspend, right? But all the other languages have this except for Java, right? So Python has async await, Rust has async await, Go has Go routines, C# has async await, right? Every language, JavaScript has async await. I mean, everything has a way to make asynchronous things look like synchronous things. It makes control flow much easier to understand, right? And it's very nice in Kotlin. You finally have it as well. You have the suspend keyword. So the suspend keyword, the integration in Kotlin, if you're using Spring Web Flux and RSocket and all that, it just works. All these APIs suddenly are now accessible as coroutines. So that's even easier and that's even nicer, less code, very elegant, etc.
I have a last question over here from Jorge Tavares, and after we're gonna raffle 2 tickets for the Cloud Conference talk. Josh, I have the legacy, and can the web client help to make old protocols like a SOAP, JAX-B, or X-oriented protocols with a sync, for example, the architecture, like
Wait, I'm sorry, I didn't understand the last part.
Okay. George Tavares asked, can web clients help to make a call to old protocols like SOAP or JAX-B, XML-oriented protocols?
Okay. So since SOAP is just HTTP, then yes, in theory, you could do that. But we do not have a reactive SOAP client. So you will have to send the HTTP request yourself, right? Which is, makes me want to take a shower. But you could, right? It's HTTP, so yeah, I guess. But there's no support. The reactive web client does not know about SOAP. It doesn't know about SOAP-based web services. So there's that, right? There's no.
I have the last.
Oh yeah, sorry.
I have the last question over here from Luis Enrique. Reactor has more two ways SSL.
I don't know. Good question. I have no idea. Does Reactor? You want me to find out? That's a very good question. For two-way SSL.
I think so.
I don't have the answer. I'm sorry. I'll Google it. I'll ask. If you send me an email, josh@joshlung.com, ask the question. I'll send it to the Reactor team and to the Reactor Netty teams who work at Pivotal at VMware on the Spring team.
Okay. Or you can put in the Twitter. Everybody can know. Yeah. Well, do you have more question, guys? For meantime, Bruno is going to raffle 2 tickets over here. for the Cloud Conference? Okay, Bruno, go ahead. You're mute, Bruno. Bruno, tá mudo. Você tá mudo.
Sorry. We pick all the list and we free team meetups groups, and we have all the subscribers, and we now you draw two tickets for Cloud Conference Day. Okay, so we have two, Thiago Dolfin, Leandro, and Leandro Rocha, right?
No, Leonardo Rocha.
Leonardo Rocha. Okay, we send the two tricks tomorrow with in the meetup, right? And that's it.
Thank you, everybody. And thank you, Josh, for your time. Amazing presentation. Everybody in the Java community is very happy. And if you want to know more about Reactive Spring, Josh just released a book in September, right now, in the end of September. I bought this book last year.
Thank you.
Were writing in the LeapUp.
This is the cover.
Yeah. And that's it. Thank you, guys.